Okay, so first I'll just explain, I guess, what we have been doing within the project. So we have been running since 2010. I'll explain what we've been doing and then go into some of the results and the implications that has on our rotations. So the idea of this project was to look at what was really happening in farmers' paddocks with their different crop and pasture sequences and track the biology of what was going on. As a part of that, we selected 184 paddocks, mostly within the medium rainfall zone, and we started monitoring those in 2010. We visited the paddocks 4 times each year, and we took measurements relating to weeds, disease and nutrients, as we thought those were the main things that people were trying to manipulate when they were using their different crop and pasture sequences. The reason that most of it's in the medium rainfall zone is because we did it in conjunction with some of the grower groups, so MIG, Wantfa, Levy and the FACEI groups. But we do have some low rainfall areas, Hyden, Woburn, and also some high rainfall paddocks down towards Kojonup. So that's what the, I guess what it was all about, trying to look at what was really happening in farmers' paddocks. And when we went to the paddocks, we monitored a 1 hectare area of those paddocks. So we were going back to the same spot in the paddock for those 5 years. What's happened so far? So we now have 876 paddock years of data through doing the project. And this gives you the breakdown of the different species that we found. So wheat, 58% of the time when we went into a paddock it was in wheat, 14% canola, 12% pasture, 6% barley, 6% lupin, and a long tail of other land uses making up this low sort of percentage that made up the rest of what was being grown or what those paddocks were being used for. Looking across the different rainfall zone, the different regions, so northern, central and southern regions, wheat and lupin was more commonly put in the northern region. Canola was spread pretty much across the whole area, and barley and pasture was more common in the central and the southern region. Pretty much what you would expect. If you have a look at the Bank West benchmarks, just looking here at from 1999 to 2013, looking at the average area of a farm that was put into each of the different species here, we see a few interesting things. Wheat, canola and barley making up 75% of what's going in that medium rainfall southern zone, and that matches up with 74% from our survey. You can clearly see there the change over that time period, with pastures being in the orange part of the graph going from about 35% area through to 21%, and canola increasing from about 10% through to 17%. If we look at the medium rainfall north, relating that back to our paddocks, we have wheat, lupin, canola in the Bank West survey making up 88% of what's going in. We had 90% made up from those 3 species. Again, the pasture story over that time period, 35% back in 99. The last survey had 5% of pastures in that region. Canola going up since about 2008 quite dramatically, that area in the purple, to about 18%. And you've even got, obviously, the wheat going from about 40% there to 53%. So some major changes in what's been going on over that time period. And it matches up pretty well with what our paddocks are showing us, so we're fairly confident that we've got a reasonable set of paddocks to work with. If we start to look at the biology now, just pH as an example, 61% of paddocks had a pH less than 5.5 in the topsoil, and 23% of paddocks had a pH less than 4.8 in the 10 to 20 centimetre layer. That matches up really well with the survey of Chris Gazy's and other surveys that have been done, which gives us a bit of confidence about the biology of the paddocks. As far as crop and pasture sequences go, the important thing about pH was that we had 15% of paddocks that were pretty good in the surface soil, so above 5.5, but they were poor at that 10 to 20 centimetre depth. So really the paddocks, the central northern region, red paddocks there, are not so good at 10 to 20 centimetres. And the implications there are that if you're sowing a pulse crop or perhaps a canola and you're only measuring 0 to 10 centimetres for your pH, in 15% of paddocks you might be putting those crops into a situation where they're not really going to perform all that well because they have acid soil at depth. When we look at the results, this is just, I just took a quick grab of 2013 data. 20% of the canola sown in that year was on low soil pH. Essentially, the canola is being extended out to the acid sandplain soils in the central and the northern regions. Phosphorous, plenty of nutrition in general was pretty good for the paddocks. Phosphorous, as an example, we had a high level of P, and a lot of paddocks had over our sort of value of 25 milligrams per kilogram as our sort of benchmark level. In the northern region, we had leaching of phosphorus down to the 10 to 20 centimetre layer. So here, around the Minganyu area, we had a lower level of paddocks, so 62% that had good levels of phosphorus in the surface soil, but there were reasonable levels at that 10 to 20 centimetre level depth. So again, measuring the soil below 10 centimetres is a good idea, and we found the same thing for sulphur. Moving on to nitrogen, we measured soil profiles at the start of each year before sowing, down to a metre, and the story there really is that summer rainfall obviously drives mineralisation and the amount of starting nitrogen that you have. The best example of that was in the central region. If we look here at the Wantford and Facey paddocks, they're central region paddocks. Great, they're running at about 100 kilograms of N per hectare for the first years of the project. A bumper crop in 2013, no rain after that until seeding, and we've got very low levels of N at sowing. So I guess that's something we need to keep in mind perhaps for this year. Looking more at the nitrogen, the effect that the legumes are having. Legumes grown in 2011 increased the starting levels of the paddocks in 2012 by about 14 units. Legumes grown in 2012 didn't have an effect on the 2013 paddocks. So it was a bit hit and miss, I guess, with the amount of nitrogen we were getting fixed. I should point out that we measure that before sowing. So the atmospheric nitrogen that has been fixed won't all have been mineralised and it won't all be available. So we're probably underestimating the amount of nitrogen that we're getting from our legumes by, I guess, through these measurements. Ron Yates was in the project and he looked at nodulation. Here he found that most of the lupin samples had ample nodulation, but when it came to the pulses, clovers and medics, about half of them had absent or moderate nodulation. And they've been doing a lot of work within the project looking at residual herbicides and the root health to try and get an idea of what's causing some of these problems. But it certainly appears that we can probably get a bit more out of our legumes than what we're getting at the moment. The bigger picture for the N story is looking at the N balance. This is an example from one of our paddocks in Kojonup. For a lot of our paddocks, we've got the fertiliser that was applied and the grain yields that were taken off. So Geoff Anderson has done a lot of work calculating nutrient budgets on the paddocks. And this example shows you, I guess the thing to get out of this one is that we're running negative nitrogen balances most of the time. We're able to get away with that because we are using stored organic nitrogen, which is fine. But if we keep doing that over a long period, there's the potential that we'll reduce our levels of soil carbon and our soil bank of nitrogen will in the long run decrease. So I guess when we're thinking that we're replacing a lot of our legume pastures and lupins with canola, this is something that we probably do need to look at a bit more thoroughly as we use less legumes in the rotation. Pastures, Brad Nutt monitored the paddocks that were in pastures, both the biomass production and the composition. Looking at it by region, in the northern region, I don't think that these pastures are really going to give us much for our nitrogen inputs. Very small proportion of legume in the pastures, so we're not getting any real benefit there. And the broadleafs really are capeweed and wild radish. So not great pastures in the northern region. Central region, things improve quite a lot. Improved legume content, but you've also still got that reasonable level of broadleaf weed in the composition. Southern region, you've got some quite good pastures, 3.7 tonne per hectare biomass production on average, and your low level of broadleaf weeds there as well. I guess just looking at the differences between the regions and explaining why that occurs, of course there's more cropping in the northern region and you've got herbicide-resistant weeds. The weed scientists have told us that we need to get our weed seed banks down to manage herbicide-resistant weeds, and the northern growers have done a fantastic job of that. But in the process, they have depleted the seed for the regenerating pastures. The question really is in the southern region, where this graph I showed you earlier showed that the proportion of cropping was increasing. What do we do in this area where pastures are still an important part of the farming system if we have increased cropping and herbicide resistance? Because we'll have to choose between reducing our weed seed banks, our ryegrass seed bank, or maintaining our pasture production. So that's probably something that comes out of this that we need to look at. Weed control in general, it was actually pretty good across most of the paddocks. We didn't walk into weed-infested paddocks too many times. 70% of the paddocks had less than 5 ryegrass per square metre at anthesis, and only a small proportion of the paddocks had reasonably high levels at anthesis. So I think it was, 6% greater than 30 plants per square metre. And of course there were more weed species, or what we would call weed species, the ryegrass in the southern area based on their higher level of pasture. This is just a grab looking at what happened during the season when different species were grown. So this is a measurement taken 3 to 4 weeks after emergence. This is at anthesis, and this is just the percentage of the seeding of that seedling sort of stage. So with the wheat, started off with a low number, went to a high number, so we had weeds increasing. Canola was being put in when weeds were relatively high and being used effectively as a clean-up crop. Barley was reasonably good as a clean-up crop, and even lupin didn't come up too badly in the paddocks that we monitored. Getting on to, I guess, the next thing, so we talked about nutrition, talked about weeds. The next one was diseases that we were interested in. We measured them in a couple of ways. The first way was using the DNA SARDI test, and generally, as a broad overview, it was good at picking up the DNA of the different pathogens in the paddocks. We certainly found the different pathogens in the areas that we expected to find them. So, for example, Pradolenchus and crown rot was found along the south coast more often. Rhizoctonia was spread throughout. Common root rot was found in the northern region. So it all matches up to what we understand about the range of the different pathogens, which was good. I guess the other question is whether the levels of DNA actually correlated strongly to the level of disease on the plants. So we also measured the level of disease on plants just to get a handle about whether that was okay. So these results are DNA tests. So it's rhizo taken as you would normally take a predictor B test commercially. And the main thing to point out is that most of the results, so 90% of the results there, are either below detectable levels or low yield loss category. and very few in the high yield loss category. There was a bit of a trend towards increasing levels of rhizo, and in 2014, this was before sowing in 2014, we saw a spike in the levels. And again, I guess that's due to a dry summer. The DNA is not breaking down because we had the dry summer, and it's still in the soil at seeding, which goes in with what we understand about the biology of the pathogens. So again, it does tell us that the predictor B test is giving us some sort of reasonable results. That same the same spike in levels occurred for all the pathogens. So I've just taken the 2014 levels here, and these were much higher than for any of the other years for all of these pathogens. But it certainly did pick up the crown rot issue that everybody saw. And for take all, really for the other years of the project, we hadn't found any take all. So that's about that one. Rhizoctonia. I guess the main point here in this slide is that what we're looking at is the DNA before sowing, the DNA at harvest. And then again, just like I was showing with the weed populations, I'm just looking at the amount of increase over the growing season. So if that number's above 1, it's increased. Above 100, it's increased. If it's below 100, we've had a decrease. The thing there is that with canola, we have been able to decrease the amount of Rhizoctonia DNA in the soil from that pre-sowing test through to harvest. And that's a fairly significant finding, because previously we thought that the host range of Rhizoctonia was so wide that we wouldn't be able to use our crop and pasture sequences to manage this pathogen at all. So that's quite a useful finding. On the other side of things, this is the same sort of table showing Pratylenchus species, pre-sowing, pre-harvest, and of course we're sowing more canola, but canola is a good host of Neglectus, so not so good. And particularly when you look at those numbers that we saw earlier in the presentation with 75% of wheat, 75% of the area in the southern region being wheat, canola and barley, it sort of points to the fact that we need to be keeping an eye out for Neglectus along in the southern region. Plant scores were also done. As I said, plants were dug up out of the paddock and sent to DAFWA plant pathologists who washed the roots and looked at them. It was common to find disease within the paddocks. We had about 74% of the paddocks at anthesis that had some plants in the sample of 40 plants that we sent in that showed disease. But for most of the paddocks, there weren't a great number of those plants that were assessed that had disease. So this pretty much shows that, just a box plot here, this is the 75th percentile showing that for 75% of the samples that were sent in, about 23% of the actual plants that were assessed had some disease on them. That's for Rhizoctonia. And as I said, for take all, it was pretty much a non-event over the years of the survey. If you look at the severity of the root disease, so this was done by looking at the area of the root that had been affected, and it was just a combination of all the diseases that the plant pathologists were assessing. There were very few paddocks that had very high levels of root disease. Again, another box plot. You can see here at anthesis the disease on the roots was greater, as you would expect. This is just a rating scale which shows here what you're seeing is about 50% of plants had 5% of the root area or less affected by disease. And you had very few roots that had very high levels of disease. So the key messages really are that the survey's been effective in tracking those changes in what has been happening in the farming system. So we've picked up that there's, I guess, a greater proportion of crop and less pasture, and we've also picked up that the legumes have been replaced with the oilseeds. Also, we have been able to measure changes in biology of the paddocks associated with those different land uses and the changes in the way that we're using the paddocks. For example, the pathogens, the different pasture productivity, nitrogen levels and other things. So I guess these things need to be considered in the long term when we plan our rotations or our crop sequences, and also perhaps for some of the research and development that comes out of this. But overall, while there were changes in the biology of the paddocks, most of the paddocks were pretty good. As I said, when we walked into the paddocks, we didn't see death and destruction. They were reasonably productive and were being maintained in a pretty good condition using the range of crops and pastures that we were seeing in the survey. I think that's pretty much about it.